This video covers two of the four features of graphs and data sets: the measures of central tendency and the measures of variability, better known as spread. Each of these tendencies have three components of them. We're going to go over center first and then spread. The mode is the observation that occurs the most. So if you have a data set, you want to look for the number that occurs the most, and that's the mode. In this data set, that number is 2. So the mode would equal 2. There can be more than one mode. So if this data set was to have an extra 1 to it, the modes would now be the numbers 1 and 2. The median is another central tendency that is often used. The median is the middle value of a data set. It divides the observations in half. So, to find the median, there are two ways in which you can find it. If you have an odd number of numbers in the data set, then the median is the middle number. Here, I have 7 numbers, and they're odd. They have to be in numerical order, and they are here. So, we look for the middle number, which would be 8. 8 would be considered the median here. It splits the data set in half, and it's the middle number. If we were to add a number to this data set, say the number 20, then our median would now actually be the average of the two numbers in the middle, the numbers 8 and 9. Notice that the numbers 8 and 9 still split the data set in half. There's 3 numbers on the side of 8 and 3 numbers on the side of 9. So the median is now the average of these two middle numbers. So the median is 8.5. It's not a number that exists in the data set, but it's still a number that would split the data set in half. And finally, we have the mean. The mean is the average of numbers in a data set. Okay? It's important to know that you must add up all of the numbers in the data set and then divide it by the amount of numbers that exists. What I want to show you here is actually numerical variables here. It's important in statistics that we use sample data to make a generalization about a given population. There will be a variety of variables that you will see that you will relate to sample data or population characteristics. Above, there are 4 variables that each have different meanings that you must be able to understand and use. So, here we have a sample mean. This variable represents sample mean. This variable represents the Greek letter sigma, which means you add up all of the values. You should be familiar with x, it's just a value in the data set. And then last we have this letter n. N means the sample size. Now we're going to move on to variability. Why is the study of variability important? There's variability in virtually everything in the world. There's variability in everything we do in this class. It allows us to distinguish between what is usual and unusual in a data set. Reporting only a measure of center doesn't provide a complete picture of the distribution. We may know the average, but people are different. We need to understand those differences just as much as the average. The simplest numeric measure of variability is range. Range is the difference between the maximum and minimum value in the data set. So if I have a data set here, numbers 20, 30, 40, 50, and 60, I would find the range by taking the difference between the two. Notice that the range is 50. The range is not from 20 to 70. It's a one value. Next, we have the interquartile range, which is the range of the middle half of the data. So now we're focusing on the middle 50% of the data. Okay? So to find the interquartile range, we need to find the quartiles of a data set. Quartiles is very close to the word quarter. It does mean the quarter distribution of a data set. So we need to find 2 quartiles, the first quartile and the upper quartile. Okay? Q1, the lower quartile, is the first 25% of the data. So to find the quartiles, we first need to find the median. So first find the median of a data set. I already rearranged these numbers in order so I can find the median. The median is the average between 15 and 15 because this is an even distribution. Therefore, the median is actually 15. Now, to find the lower quartile, I want to look at the first half of the data set here. So I want to look at numbers 5, 9, and 15 here. The lower quartile is the median of the lower half of the data. So I have 3 values there. My lower quartile would equal 9. Now I want to find the upper quartile. So I need to look at the upper half of the data. And I also need to find the median of the upper half. Again, we have 3 numbers because our medians cut the data set in half. Therefore, the upper quartile is 19. To find the interquartile range, we take the difference between those two, and thus we have our IQR, which is 10. It works the same just as with an odd data set. So our median here is 10. Our lower quartile would be 8 because it's the average between 7 and 9. It's the median there. So our Q1 would equal 8. And our Q3 would equal 11 and a half. Therefore, our interquartile range is 3.5. The final measure of variability is standard deviation. So, to measure variability, we need to find the deviations of a data set, meaning we need to find the difference between each value and the mean. That is what a deviation is, the difference between a value and its mean, okay, and the mean of the data set. Once we have the estimated average of the deviation squared, we call that a variance. Variance is important because variance gives us the standard deviation. The standard deviation is the average distance each value is away from the mean. There is a formula on the next page for this. So, how do we find the standard deviation? Okay, so the most important thing is to have our mean of a data set. So the mean of this data set would equal 6. Once we have the mean of our data set, we need to find the deviations between each value and the mean, meaning we need to subtract the mean from every single value in this data set. You must include negatives. So we have our deviations now. Now in statistics, we don't really want to deal with negatives too much. So we have to square each value here. And that gets rid of the negatives. Now, after we square each value, we want to add it up together because we're trying to find the average distance away from the mean. So now we're just trying to find the mean. We add up all the values. 35 plus 25 makes 60. And thus, we have all of our deviations added up together at 60. Now we want to divide it by the total number of observations that we have. Now, in statistics, there's a plethora of error. So when there's error, we want to try to account for as much as possible. So instead of subtracting from the sample size, we want to subtract from the sample size of 5 minus 1, which will give us 4. So our variance in this problem is 15. The variance is the standard deviation squared. So if we want to find our standard deviation, we must square root the variance. And thus, our standard deviation is 3.87. So what does this 3.87 mean? What it means is that the average distance that each of these values are away from our mean of 6 is 3.87. Given that these values are what they are, this tells us a lot about how spread out they are. If they're that far away from 6, then that means that it's a varied distribution. To conclude this video, I just want to talk about some of the important aspects of AP statistics. In AP statistics, the goal is to use sample data to make a generalization about a given population. There will be a variety of variables that you will see that will relate to sample data or population characteristics. Below, not above, there are 4 variables that each have different meanings that you must be able to understand and use. So what I have here is the population mean versus the sample mean. We use variables to differentiate between population and sample. When talking about a population characteristic, population parameters are used. Parameters are typically unknown and estimated using sample data. One example of a population parameter is the population mean. It's denoted by using mu, the lowercase Greek letter mu. When talking about sample data, statistics are used. Statistics are values calculated from samples. One example of sample statistics is the sample mean, which is denoted using x hat, which is called x hat. It's an x with a bar over it. That's all I have for our first video. Make sure that you take some solid notes, review anything that you need, and come prepared to class with questions. Thank you.